Hi, my name is Emi Kimura. I'm an Extension Agronomist and Peanut Specialist in Texas A&M AgriLife Extension in Vernon, Texas. Vernon is located in North Texas. I'm about 20 miles south of Oklahoma border, so I get to work with some specialists and county agents from Oklahoma State University as well. In this video, we would like to briefly introduce the research conducted in Texas with the main objective including agronomy, breeding, weed and disease management, soil health, soil fertility, and economics and marketing. As a part of my peanuts responsibility, I oversee statewide variety trials. This is a very important program for us, an extension program that to provide up-to-date information to our growers. So Texas grows all 4 market types of peanuts. About 40% of planted acres are runner type, and we have 20 to 25% each of Virginia and Spanish types. And we also have about 14 to 15% of Valencia types. So it is important to have all market types in our variety trials and plant that in 4 different peanuts growing regions in Texas. So that we can provide best performing variety in each region in different climatic conditions to our growers. County agents also play a significant role in the statewide variety trials. They introduce us very good farmer cooperators. They also conduct a field day in the variety trials location. So that's where we can have a good interaction with our peanuts growers and exchange information, update our ongoing research, and also get to understand any emerging issues they may have so that we can bring those issues into our applied research, try to solve those issues and answer any questions they may have. In addition to variety trials, I conduct applied research to update agronomic practices for Texas growers. This year, I'm conducting fertility trials. One of them, I'm using 4 important nutrients in peanuts, including calcium, manganese, boron, and supplemental nitrogen in case of nodulation failure. I made 14 combinations out of those 4 nutrients and apply that into runner type peanuts and Spanish type peanuts and see what kind of influences we may have from interaction of those 4 nutrients into yield and quality or grade of the peanuts. We appreciate peanuts producers, peanuts industry, Texas Peanuts Producers Board, National Peanuts Board for providing us funding to conduct this research and extension activities. I hope you enjoy the rest of speakers' presentations in this video. If you are interested in specific topics, you can click on the link next to the speaker's name in the description below so that you can get right into the specific topic. And I really appreciate your time spending with us today in this virtual Peanuts Field Day. I hope you have a wonderful rest of the day. Thank you.
Good afternoon. My name is john.cason. I am the peanut breeder for Texas A&M AgriLife stationed in Stephenville, Texas. And I wanted to take this opportunity to give you a little overview on my program and what we do. At the Stephenville Center, one of our main responsibilities is the oversight and coordination of the statewide advanced line trials. Texas is sort of unique in that we have some pretty diverse growing conditions from the southern plains to the high plains and the rolling plains, central Texas, south Texas. We're able to test our varieties under lots of different growing conditions, and that gives us a really good opportunity to see what the potential is of these varieties. And I oversee that. This year we have about 9 locations scattered all over the state where we are testing 20 varieties of runners, and then we have about 20 varieties of Spanish that we're testing on a less extensive testing, and then we also have a few Virginia trials. So as part of this, my responsibility is to just evaluate the lines that have the potential for release prior to sending them to Texas Foundation Seed Service. And then it's kind of the end of the line for the breeding program, in that these lines we will pick some for release that we will then apply for release through the Texas A&M system. However, we do have several populations that we feed into that we also, the breeders that are employed by Texas A&M feed into that testing system. We have a drought tolerance program that's headed by Dr. Mark Burra in Lubbock, and also he handles an earliness program. And he is developing lines using molecular markers to move drought tolerance into peanuts. He has identified some lines out of India that he is currently using molecular markers. I think he has about 21 molecular markers that he's selecting for drought tolerance. And we have some very promising lines in our advanced line test, and more on the way. Also, as part of that, we have a yield and grade populations that we develop, just populations that we try to maximize yield and grade for farmers and give them the most profitability that we can. And then finally, one of our big programs that we've always maintained is the multi-disease resistance program. We have several diseases that Dr. Charles Simpson has identified in exotic germplasm and integressed into our cultivated peanuts. Probably the biggest of these is nematode resistance. We were the first program in the world to release a nematode resistant runner peanut, and we continue to develop new and improved varieties. As we move back a little further out, we also are involved in just research, where the development of new technologies. We have instituted a UAV program that we are involved in with Stephenville. We're finishing our first full year of UAV flights. We have flown every week at one location this year, and we are going to be able to get some really interesting data. We hope off that, and we feel we are going to. Probably we will be able to identify seedling emergence, seedling vigor, mid-season vigor, maturity, several different things that we will be able to use to make breeding decisions. And in addition to that, we have also, one of the most exciting things that we're doing is we are instituting the use of Raman spectroscopy in our breeding program, where we can identify lots of different traits and basically get a genetic fingerprint for the varieties and the breeding lines that we're developing. So that's just a short overview of what we're doing, and I appreciate you taking the time to listen. Thank you. I'm standing here with our cooperator at this location, Mark Allison. He's a peanut farmer in Comanche County, Texas, and we're going to ask him a couple of questions and see what his thoughts on some of our new varieties coming out. Mark, what do you look for in a variety of peanuts?
Well, of course, yield, and I guess the list would be yield, and then the harvestability of the vine and so forth. That would be number 2. And disease resistance. Disease resistance. Yeah. So that may be 2 or 3. Might reverse those. I don't know.
Do you have many nematode problems here in Central Texas?
I am rotated long enough that I haven't had much in recent years, but I see just little spots of them here and there, and I know if I don't keep a long extended rotation, I will.
Yeah.
And I'm getting old enough, I don't have many years, so I don't want to extend too long. So I am scared of some nematode problems in the future.
What is your rotation?
Well, it varies. Just normally, I'm peanuts, wheat, corn, wheat, peanuts, or corn, wheat, corn. In other words, 1 in, 3 out.
Yeah. Okay. Well, great. Well, we appreciate you taking the time to talk to us.
Yes,
okay.
You're welcome.
First, I want to talk about our appreciation of the Texas Peanut Producers Board and the National Board and the Peanut Research Foundation for the support that they've given us over the years. Especially the Texas Peanut Producer Board has been a long-time supporter of our program, and we much appreciate it. Good morning. I'm Charles Simpson. I am a Professor Emeritus at the Texas A&M AgriLife Research and Extension Center at Stephenville in Stephenville, Texas, where we maintain and utilize one of the most complete wild peanut species collections in the world. And I want to talk a little bit about what we do with that collection today. I'm joined this morning by the greenhouse manager, Jamie Shoemaker, and two of our Tarleton College students that are assisting in the process as well. And I want to talk about what I'm doing now that Dr. John Cason has been promoted into the project leader of peanut breeding here at Stephenville. My objectives now are to be a pre-breeder, and that is pre-breeding of materials from the wild species to transfer genes out of wild into the cultivated. And we have a track record of doing that. We accomplished our first transfer completed in 1999 when we released the Cohen nematode resistant line. The program is our main accomplishments center around what we call integration of genes from the wild peanut into the cultivated. Now, working with the wild species presents a bit of a problem in that most of the wild peanuts only have 20 chromosomes. The cultivated peanut has 40 chromosomes. So when we when we want to cross, there's one group of materials of the wild that will cross directly with the cultivated peanut, but when you cross them, 20 with 40, you get a chromosome count of 30 in the offspring, which is highly sterile. So we have to do some chromosome manipulation, and we use what we call bridge species, and that is how we develop the nematode resistance by developing this Texag 6 that I'm standing beside. Our development of Texag 6 came from crossing Cardinacea with Diagoy and getting a fertile diploid hybrid, that is 20 chromosomes, and then we crossed that to Metizacoi, which is also 20 chromosomes. That hybrid was highly sterile, but we doubled the chromosome number to 40, and then we were able to make the cross with the cultivated peanut with 40 chromosomes. And that developed from Texag 6. We transferred nematode resistance, but we also transferred leaf spot resistance, web blotch resistance, rust resistance, and now we know that Diagoy also has resistance to tomato spotted wilt. So we use the Metizacoi actually as the bridge species. At the time in 1976, that was the only B genome, or at least non-A genome material that we had collected at that point. We have more recently collected this species here, Arachis balsi, and this one is going to be, for the future, a major player in the integration of genes from the wild peanut, because it crosses with so many of the material that cross with the cultivated, but it also crosses with things that are very much isolated from the cultivated peanut. For example, the flugy species is one that is very distantly related to the cultivated, and this balsi will cross with that, as well as the one behind me here, the Paraguayensis. It'll also cross with this one of the small leaflets, and it'll cross with this one and these two here. So it's going to be important in the integration of many different kinds of genes into the cultivated peanut in the future. So the wild species collection, and it's my opinion, and a lot of people agree with me, this is going to be a very important part of the development of better peanut varieties in the future. So it will be part of the major development of new peanut varieties in the coming years. Thank you for your attention.
Hello, my name is Pete.dotray. I'm a weed specialist with Texas Tech University and Texas A&M AgriLife Research and Extension Center. I'm down here in Gaines County. It's September the 23rd. We're a couple of weeks away from peanut digging, and I'm trying to take end of season evaluations on a variety of trials that were conducted down here in Gaines County. Always very much appreciate Mr. Chuck Rowland for the opportunity for us to do some peanut work on his property. We've done so for a number of years. Chuck doesn't have a whole lot of weeds, so primarily our focus at this location is looking at peanut response to a variety of different herbicides, both old and new. One study is looking at the herbicide Zidua. Zidua recently was labeled for use in peanut early post-emergence. We're looking at early post-emergence, mid-post-emergence, and even some at-crack applications. A few different rates, just looking at overall peanut response, and we'll be taking these trials to yield. Also looking at an older chemistry, Solacam, active ingredient norflurazone. I'm not aware of a lot of growers that are currently using Solacam in the Southwest. It's been a while since I've looked at it, so we're looking at a couple of different rates of Solacam at a few different application timings very early in the season. And then lastly, we continue to evaluate the herbicide Strong Arm. Of course, Strong Arm was labeled for use in peanuts back in 2000. The launch year, there was pretty significant peanut stunt and some stand loss. Since then, labels have been changed. In fact, currently, there is no label for Strong Arm to be used in the Southwest, in Oklahoma, in Texas, and in New Mexico. But we continue to evaluate it. Strong Arm is a pre-emergent herbicide, but there may be some more safety in the Southwest if it's used at crack or later. We definitely did see some injury from pre-applications, but the at crack and later seem to be pretty safe. Again, not currently labeled, but opportunities maybe for some label changes in the future. Another trial at this location is looking at some Group 15 herbicides. Group 15s would be products like Dual, Warrant, Outlook, Zidua, just looking at a series of applications early in season and just evaluating peanut response there. Some of those particular plots received 3 or 4 different Group 15s, and we've been evaluating for any stunt, and again, those plots will be taken to yield. And then lastly, at this location, we've got a couple of trials. One of the trials was initiated from a colleague of mine, Dr. Eric Prosko from Georgia, and Eric was interested in looking at some very low rates of dicamba, some simulated drift. When the drift event occurred 2 or 3 times during the growing season, we're looking at different low rates or concentrations, sequential applications, certainly looking for visual injury. We'll be taking those plots to yield and looking at grade as well. We also decided to look at the herbicide Enlist Duo as well in a very similar manner, a series of very low rates, sequential drift events, and we'll be taking those plots to yield and looking at grade. And then lastly, from a peanut weed control standpoint, we have a couple of trials in Lubbock County, not a traditional county where peanuts are grown, but an opportunity for us to examine some weedier locations, looking at a systems approach or a series of applications from pre-plant incorporated, at plant, early post, mid post, and a couple of the herbicides that we're focusing on those locations. Number one is Pursuit, the value of Pursuit from a broad spectrum broadleaf weed control, and also looking at the value of Strong Arm. Again, Strong Arm not labeled for use in the Southwest. Strong Arm is a very effective soil residual herbicide, and it's been proven to be an exceptional base herbicide, followed by some early posts, and we're still seeing very clean plots now towards the very end of the season. Again, I just like to acknowledge the grower, Mr. Chuck Rowland, for the opportunity to work here on his land. Also would like to thank the Texas Peanut Producers Board and the National Peanut Board for funding some of the projects that we're interested in to try to gain more knowledge, more information about peanut response and weed control systems in the Southwest.
My name is Joshua McGinty. I serve as Extension Agronomist for South Texas. I cover an area roughly from the Rio Grande Valley up to Houston and west out to the Winter Garden area south of San Antonio. Today we're standing in a peanut field near Derby. So we're south of San Antonio. We're in an area that on average hosts between 20 and 25,000 acres of peanut each year. This area is definitely unique. small pocket of production here that's not connected to any of those areas in the surrounding area of South Texas. The soil is different here, the climate is different here, the pests are different here, here in Ascosa, Frio counties, the surrounding area, and that presents a little bit of a challenge to us in terms of plot work and research, because we don't have a research station right in the middle of this. So that means we need to extend out and do research work on farm right in the producer's backyard so that it's relevant to them. And so in the case of this trial specifically, we're looking at weed management. In this case, we're looking at a lot of different herbicide options available to the peanut producer. I think this is very relevant right now given the status of all the herbicide resistant weed issues that we see across the country, because we want growers to understand all the tools, the spectrum of tools that they have available to them. So in this trial, we're looking at a lot of different pre-emerge options, and in this case, everything is also paired up with Sonalan through the pivot, and then we look at a lot of different post-emerge herbicide options, so that the grower can see what's working well on the spectrum of weeds that they face right here in this area. The other thing we like to do is look at commonly used products that are seeing widespread use here, and pair those up with products that growers aren't necessarily considering, kind of fringe herbicides that are registered perhaps, but don't see wide acreage use. And so the grower may not be aware of what's actually working well on some species that they're facing on their farm. So we can pair those up, put them head to head with some of the local standards, and show these off to growers. So obviously a trial like this is dual purpose. It serves as a research project. We are doing replicated plots here, so good solid data, but we also use these for outreach efforts. So we can bring growers by on a field day, a crop tour, what have you, and show them and let them get hands-on with this kind of research project. This project does take a little bit of time and effort, travel, again, because we're not dealing with a research station in this area. So we do appreciate the Texas peanut producers for giving us the support to make this happen and the tools to let us carry out this work. If you have any questions on what we're doing here, please feel free to reach out to me. I'm located in Corpus Christi, but I'm easy to get a hold of. My phone is 361-265-9203. My email is my first name, last name, joshua.mcginty, that's M-C-G-I-N-T-Y, at ag.tamu.edu. I'd love to visit with you. Also, if you have any ideas for projects to be done in this area, stuff that maybe we're not covering already, I'd love to visit with you. In AgriLife Extension, that's really what we rely upon, is the feedback from the growers to help drive what we do as far as demonstration plots and research. So please get a hold of me, let me know. Thank you for your time, and thank you again to Texas peanut producers for giving us the funding to do this.
My name is James.Grichar, and I'll talk to you a little bit about the South Texas portion of our herbicide research program. This is in coordination with Peter.Dotray's work out of the High Plains area of Texas. So we have the state of Texas peanut production area covered with different weed issues, whether it's herbicide tolerance or resistant weeds or problem weeds that we're seeing in different areas. As Josh mentioned, this site here is more of an on-site for grower information, that type of thing. We also do a lot of herbicide work at Yoakum, where I am able to identify certain weed species that we need to look at new herbicides, look at herbicides that we're trying to develop new programs for, and that type of thing. So we have herbicide tolerance studies at Yoakum with Solacam, with Anthem Flex, with Strong Arm, with Zidua, and that type of thing. Also has some drift studies going on there. And then we have some weed efficacy studies looking at Anthem Flex, Solacam, pursuit herbicide programs, and some coordinated work between researchers in the Southeast and Peter.Dotray and myself. So we try to cover any new weed issues that we see in South Texas, problem weeds that we don't have any information on. And as Josh mentioned, if you have any issues with herbicides or weed control in peanuts, don't hesitate to give us a call. Thank you.
I am Paul DeLaune. I'm an environmental soil scientist at Texas A&M AgriLife Research here in Vernon, Texas. So this is a peanut cotton rotation study that we're conducting here in Vernon, and it's duplicated in Lubbock, Texas with Dr. Katie.Lewis. But we're looking at conservation tillage and use of cover crops in peanuts. So this study that we'll look at today is looking at different cover crop species and seeding rates and use of strip till for peanut, and we're looking at peanut yield, grading the peanuts, as well as the soil health and health of the rooting system of peanuts as well. So this study, we planted rye various rates, for instance 30 pounds per acre up to 90 pounds per acre, and then we have a control that has no cover crop, that is strip tilled, and then we have radishes planted at 10 and 30 pounds per acre. We're also comparing organic versus conventional cotton peanut rotations. We're looking at the conventional system today. One thing we found about seeding rates, higher seeding rates does not equal higher biomass production. With our 30 pound per acre rye and our 25 pound rye with 5 pound of vetch mix produce about 3,000 pounds of biomass, whereas our 90 pound rates and our of either straight rye or a mix with vetch only produce about 1,500 to 2,000 pounds of biomass. So higher seeding rate did not pay in this case, and we've seen that in other studies as well. One thing with the cover crops, we were concerned with how would this affect emergence with heavy residue, and we saw no issues with germination or stand establishment with these cover crop residues. And we rolled the cover crop residues and then terminated them chemically for the conventional side. There was a little bit of concern. We had heavy rains shortly after planting, and the cover crop plots that had a lot of residue, they did remain wet and very saturated for a longer period of time because we retained a lot of that moisture, but in the end it didn't affect cracking or stand establishment. So over time, some other things we have looked at is soil health, and a grad student looking at some of the rooting characteristics and mycorrhizal fungi associations with the rooting system. And we've seen some encouraging results where we do see an impact of cover crops on soil health in the soil and also with the roots. So with time, we'll see how that translates to yield and productivity.
Hi, my name is Katie.Lewis. I am an associate professor with Texas A&M AgriLife Research and Texas Tech University in Lubbock, Texas. My research program focuses on nutrient management in both peanuts and cotton. We also evaluate the effects of cropping systems and cover crops on soil health and nutrient cycling, as well as looking at the interactions between cropping systems and nutrient management with the goal of optimizing nutrient use efficiency. The peanut fertility trial that we have initiated this year is in response to questions and concerns that were raised by peanut farmers across the High Plains or Southern High Plains in regards to calcium availability and uptake and potential deficiencies that they were seeing across their peanut fields. There are several reasons that calcium may be concerning or an issue when it comes to availability in peanut production. First, before I get into those, calcium is a nutrient that is the predominant exchangeable cation in the soil. Magnesium is also present in very high concentrations, and so you might ask, why are there availability concerns? Well, there are reactions that can happen in the soil, especially as pH increases or decreases, that can not only limit its availability, but also its mobility in the soil. Mobility is one of the reasons that we do have availability issues. It's not always at that right depth when it comes to peanut production. There can also be issues, like I said, as pH decreases. That's why often in more acidic soils, gypsum is necessary for peanut production. In our region, we have more alkaline soils, and so gypsum applications are not very common. calcium uptake in peanuts is very different or unlike any other crop. So typically a crop takes up calcium through its roots, and then it's partitioned to the vegetative parts, and then eventually the fruiting structures of the plant. Well, with peanuts, calcium is taken up directly by the pegs into those fruiting structures. It's not necessarily partitioned throughout the plant. And so with that being said, calcium must be present in the top 3 inches of the soil in order for that peg to take up and utilize the calcium. This is one of the major reasons it's important that we not only look at calcium in the top 6 inches, 12 inches of the soil, but also what's available in that top 3 inches. And so because of these reasons, we initiated a peanut fertility trial that's evaluating the application time of calcium. We're using a calcium nitrate product. It's CN9, and you might ask, why are we applying nitrogen? But peanuts, even being a legume, still need a small amount of nitrogen early on in the season just to get them started and going. And so we're looking at CN9. It's a product that is made by Yara International, and we are applying it pre-plant. We're also looking at it 3 weeks after emergence, as well as in furrow, to evaluate when the best application time is. Some of the parameters that we're measuring, we're looking at calcium uptake by looking specifically in the amount of calcium that's taken up by those pegs throughout the middle of the growing season. And then of course, we'll be looking at yields. I can't wait to share those results with you. Thank you.
Hi, my name is Cecilia.monclova. I'm the Extension Plant Pathologist at the Lubbock Center. My specialty or my focus is with cotton and peanut diseases. When we talk about peanut diseases, the number one question that you have to answer is what is causing my problem? So for that, you need a proper diagnosis. So today I'll talk about a few of the diseases that are commonly observed across Texas, and also some of the projects that we're working with. Number 1, peanut root knot. In this case, you can see the galling caused by the females on the pods. The females can also infect the root system. And remember that the peanut root knot is a different species from the cotton root knot. The second disease is the Sclerotinia minor. This one is usually confused with white mold, and you can see it developing on the shoots near the crown area and also on the pods. Over here, it is characterized by this white mycelia that will start growing, and then it will form a little bit of circles of mycelial clumps basically on it. And that's the way to diagnose it. The most common peanut disease is the peanut pod rot. This one is caused by a disease complex including Pythium, Rhizoctonia, and sometimes even Fusarium. Each one of them have different symptoms. Usually Pythium looks more like a water-soaking lesion on the pods, while Rhizoctonia looks more like a dry symptom. When you see Fusarium on it, usually Fusarium will give about like a pink or a violet purple color to the pod, and that is the way to diagnose it. And finally, leaf spots. There are many leaf spots out there that can appear on your peanuts, but one of the most common ones are the early leaf spot, which is a light brown to dark brown color with the yellow halo, and the late leaf spot, which is more of a dark brown to black color, and usually it doesn't have that yellow halo to it. In the plant pathology lab, we have 2 major projects working with peanuts. One, we are testing fungicide effectiveness or impact in the pod rot fungi. So in this case, we selected 2 different varieties. One susceptible, Georgia 09, which is the preferred variety in our area for growers. And then we also have Lariat, which is a resistant variety for pod rot. And in this case, we are testing different fungicides and see the effect of them into the development of the disease. And not only different fungicides, but also different timings for up to 6 different applications across the season. All of these ones are foliar applications. The second project is evaluating fungicide effectivity on pod rot fungi. In this case, we are conducting a survey where farmers across Texas are sending samples to us in collaboration with crop consultants and also extension personnel. When we receive them, we do some isolations, and then from that one, we will test 4 different fungicides to test the sensitivity of them. With this, we are looking to test if the fungi that is out there in the field have developed some resistance to these fungicides that are widely used, either as a seed treatment or has in-season applications. With this kind of information, we will be able to inform the industry and also farmers to make better selection for control of pod rot fungi. If you have any questions about diagnosis or how to do management, just please feel free to contact me. I will leave my contact information below so that way you can get a hold of me. Thank you.
Hello, my name is Francisco Abello, and I am an assistant professor and extension economist for Texas A&M AgriLife Extension, and I'm located here in District 3 in Vernon, Texas. So as part of our program here in Vernon, we work in extension and on applied research in crops and livestock economics for District 3. We work on wheat, cotton, peanuts, specialty crops, cow-calf stockers, and any other production that we believe is important or will have a significant impact in our areas. We look at the overall production system in the area. We also work on farm branch management, business economics and finance, risk management and marketing, and any other agricultural economics areas such as policy updates. So our goal is to deliver the economic tools that will support your decision making and ensure economic sustainability of your business. On my website, you will find a link for the latest resources, market information from our research center as well as from our department, Excel spreadsheets with decision aids on different topics, as well as economics budgets for crops and livestock, including, of course, peanut production for the different districts of Texas. On the peanut budgets that we have for irrigated land, we include all variable and fixed costs. We also include depreciation and opportunity cost. I will encourage all of you to use these tools and compare yourself with the cost and be sure you're including everything. You might have some little difference depending on when did you purchase your inputs, how do you manage the land that you have, and the yield that you are expecting. But this is a great tool to compare yourself and know where you're standing, especially now, given that market prices are just a little below or above, depending on your total cost of what the total cost per ton is. So I would like to thank all Texas peanuts producers and the Texas Peanut Producers Board for supporting our research here in Vernon, Texas on peanuts. And also please do not hesitate to contact us for any questions that you have. So thank you very much.